Okay, question 11, and this is moments. So we've got a uniform rod of weight 20 and length 2.8, resting in equilibrium with the end A in contact with rough horizontal ground, and the B is resting against a smooth wall, which is inclined at 55 degrees to the horizontal. The rod, which rests in a vertical plane that is perpendicular to the wall, is inclined at 30 degrees to the horizontal. Show that the magnitude of the force acting on the rod at B is 9.56 newtons. So, just zoom in on my diagram and let's get some forces on. So there is going to be a reaction force down here at A, which acts perpendicular to the ground, and we're told somewhere that it's rough horizontal ground, which means that there is friction as well. Okay, so let's call that FA. It's a uniform rod, which means weight acts at the center, and we're told that the weight is 20 newtons. And then finally, we are going to have a reaction force at B as well, and this is going to act perpendicular, so kind of in this direction, to the wall it's resting on. Okay, so we want to work out the magnitude of the contact force, so that's this RB here. So what we need to do first is we need to take moments around A. Okay, hopefully your teacher or whoever has told you that most questions you're going to be taking moments around A. The problem at the moment though is we don't know what the perpendicular forces or directions are. So let's start with the weight. Okay, so this rod was 2.8 meters, which means to the center we've got a 1.4, and if I kind of draw out a little triangle, we've got something like this. Well, this is 30, this is 1.4, and then this is 20 newtons. So I want to know what this distance here is, because that will be the perpendicular distance to the force. Okay, now this is adjacent to the angle, so it's going to be 1.4 cos 30. So the moments is going to start off as 20 times 1.4 cos 30. Okay, and that's kind of going in the clockwise direction. Now let's take a look at this reaction of B up here. Again, this is not perpendicular at the moment. So what we need to do is we need to work out this component here, because this component here is perpendicular to the rod itself, which is 2.8. So this is going to equal the length, which is 2.8, multiplied by the perpendicular component of that force. So we need to do a bit of angle chasing here. This angle here is 125 degrees because it makes a straight line with this one. That means 30 and 125 makes 155. So altogether what's left is going to be 25 degrees. However, that then means that this angle here is 65 because the whole thing is a right angle and 90 take 25 is 65, which means the component we are looking for is going to be RB sine 65, like so. Okay, just a quick note, you could have done it by considering this component here. Okay, and if you did that, you would have got the same thing basically, but cos 25 instead. Okay, so let's rearrange to get RB on its own. Well, this left-hand side is going to stay the same. So 20 times 1.4 cos 30 divided by, and then we've got 2.8 and a sine 65. Okay, and I'm going to plug all this in my calculator. And what it gives me is 9.555 ... So to three significant figures, this is going to be 9.56. And that's exactly what we were trying to show. Okay, brilliant. So part B, determine the magnitude of the contact force between the rod and the ground. Give your answer correct to three significant figures. So what we need to do here, we need to find FA and we need to find RA. So again, hopefully your teacher has told you The other part of these questions is you will need to resolve vertically and you'll need to resolve horizontally. So let's just take a look at all my components. I can see this is okay, this is okay, this is okay. It's the reaction at B that's causing a bit of issue. So let's zoom in. And I'm going to just rub a little bit out. So let's see. So we're going to rub this out. We're going to start again. We know that the reaction acts perpendicular, which was this, and we know what it is now. It's 9.56. So the components we need now are the horizontal and the vertical, like so. So again, we've got to do a little bit of angle chasing. Last time we saw that this angle here was, I think, 25 degrees. This angle in here is actually 30 degrees because we've got alternate angles kind of here. And then all together, again, the whole thing is right angle. So this angle here has to be 35 degrees, which means that the vertical component is going to be RB sine 35, and the horizontal component is going to be RB cos 35. That's in those two directions there. So we're now ready to resolve. Let's start with vertically. So we've got RB sine 35 acting upwards. We've also got RA acting upwards. And we've got 20 acting downwards. Let's do the same for the horizontal. We've got FA acting to the right. And we've got RB cos 35 acting to the left. Okay, so from here we get RA is 20 minus 9.56 sine 35, because that's what RB was. And here we've got FA equals 9.56 cos 35. Okay, good. So we've worked out RA and FA. Determine the magnitude of the contact force, which means we need to do Pythagoras on these two things. Okay, so the magnitude is going to equal the square root of, let's start with this one, 9.56 cos 35 squared plus 20 minus 9.56 sine 35 squared. I'm going to shove all of that into my calculator and let's see what I get. So overall, to three significant figures, I get 16.5 newtons, and that is my final answer there. Really hope that helps. Moments is a tough topic, so make sure you know how to resolve forces in any direction. See you for the next one.